Bioremediation. What is bioremediation?
Bioremediation is the use of organic agents to detoxify environmental contaminants. These organic agents essentially degrade by using the contaminants as a food source, thus eliminating the pollution from the area. Agents including trees, fungi, and microorganisms are used to treat contaminants such as oil, petroleum products, solvents, and pesticides. There are two methods of bioremediation: in situ or ex situ. In situ is on-site treatment. This process brings the organic organisms to the contaminated sites. By treating the problem close to its source, the process of bioremediation is sped up. Ex situ, on the other hand, brings the contaminants to the organisms. This process involves excavating contaminated material and transporting it to a treatment site. In situ is more convenient and efficient, as it can treat the problem at its source. The application of either method can be completely organic or can use the assistance of human engineering. Intrinsic is a natural type of bioremediation. It relies on soil's natural processes to degrade contaminants without taking any engineering steps to enhance the process. Engineered bioremediation is a type of remediation that uses engineered systems to supply nutrients and growth-stimulating materials to increase the efficiency and degradative activity of microorganisms. Engineered bioremediation may involve using drills, pumps, or even genetically engineered microorganisms to speed up the process. Engineered bioremediation tends to work more in hand with microorganisms, where intrinsic bioremediation can use plants and fungi in addition to microbes. Microbial remediation is when hazardous waste provide carbon and electrons which microbes can use as a food source to stimulate their own growth and reproduction. They do this through gaining energy by catalyzing energy-producing chemicals through oxidation-reduction reactions, where contaminant is the donor and the microorganism is the acceptor. Electron donor and acceptor are essential for cell growth and are commonly called the primary substrates. When present, oxygen will be used by microorganisms as an electron acceptor in a process called aerobic respiration. In the absence of oxygen, they use anaerobic respiration. This is where microorganisms use a chemical other than oxygen as an electron acceptor. Common substitutes for oxygen are nitrate, sulfate, and iron, and sometimes even manganese or even carbon dioxide. Sometimes the microorganisms will use fermentation, where organic compounds in the waste are used both as electron donor and electron acceptor. In other cases, the contaminant may not be able to serve as the primary energy source for the organisms. This requires the presence of other compounds, primary substrates, that can support their growth. Engaging in microbial remediation sets you up for successful phytoremediation, allowing plants to survive under less than ideal site conditions.
When plants are present in the soil, erosion is reduced and more microbes are present in the plant root zone. 6 ways plants help heal the land are through phytoextraction, photodegradation, phytovolatilization, photostabilization, and rhizodegradation and rhizofiltration. During phytoextraction, plants pull up contaminants, mostly metals and radionuclides, with their root zones and accumulate them with their stems and leaves. During phytodegradation, plants pull up chemicals up to their leaves and break them down through the release of enzymes and through metabolic processes. Photovolatilization is when plants take up volatile chemicals and release them into the atmosphere through transpiration. The contaminant is either transformed within the plant into a less toxic state and then released into the air, or is released as is and then degraded by the sun. Using photostabilization, plants can bind or mobilize contaminants by absorbing them into their root zone and releasing the chemical that converts the contaminant into a less toxic state. This method limits the movement of contaminants through erosion, leaching, wind, or soil dispersal. With rhizodegradation, some of the root zones of certain plants can provide an ideal environment for microbial degradation, and in some cases, plant root zones can filter contaminated water by absorbing contaminants into their roots and plant tissue, similar to phytoextraction. This is a process called rhizofiltration. Mycorremediation is the use of mushroom and fungi to deal with contaminated soil, decrease erosion, and help recharge and heal the damaged land. This requires a lot of mycelium, which are the vegetative parts of fungi. These are dense networks of ultra-fine, thread-like white hyphae. Filters made from mycelium can trap contaminants in runoff and polluted water, and myceliated straw can be used to absorb spilled oil. Biodegradation is a more cost-effective and healthy way to help heal our planet.